Hello again, all you Javaites. Today is another lesson in our series on intermediate Java programming, and we're gonna switch a little bit. I've been talking about object-oriented programming. We talked a little bit about graphical user interfaces. Now we're gonna take a step back and we're gonna look at input and output very specifically. And up until now, you've lived in an input-output world that's been keyboard and screen. And what we're going to try to do in the next few lessons is expand those horizons a little bit. So first we're going to look at files, and then if we have a chance we'll look at things like accessing databases or the web or something like that to expand the reach of your program and what it can do. And so today specifically we're talking about Java file access. And the first sort of disclaimer I have to give you is that we're talking about Java here. And one of the great things and troubling things about Java is that it can do so much, which makes it very complicated sometimes. And it turns out that with file input and output, things can get very complicated in Java. And for the purposes of this video series, I'm going to be simplifying that access down to the bare core of what you need to know. And we're going to start with talking about streams. I need you to start to think about accessing information, whether it's from the keyboard or whether it's from a file, in terms of streams of bytes. That's the terminology that's often used. When you access, let's say someone types in their name and hits enter, what's happening is that information is getting into your program as a stream of bytes. One byte at a time. Each letter, let's say, or part of each letter at a time is coming through. And that's just information. Really, it's actually just data. Your program has to take that stream of bytes and interpret it as, oh yeah, these are characters that I'm reading in. Or, you know what, I'm going to look at this as a binary number or an individual character or a bunch of booleans, or right? So the data is being streamed in, and what you're doing is interpreting it. And Java is going to have a number of different classes which will allow you to access and interpret that stream in different ways depending on the use that you want. So far you've dealt with the default input, which is the keyboard for computers. And so far for output you've dealt with the screen, system.out. There's also a system.err, which is used for like error messages, but this is basically the world that you've lived in so far. So one of the things that, if we just look at characters for a second, because it's really what we're going to be focused on in the first few videos is characters. Remember when we talked about characters are usually represented as ASCII. And so when you think about streams of bytes, that's the information that's coming at you as those ASCII bytes. Now in Java, as in many things nowadays, ASCII is not entirely really what's used. There's a different system called Unicode which allows for a greater array of languages and characters and things like that. But the principle is the same. Something in a string gets translated into bytes and it's stored in a file. It gets read as bytes in a stream into your program and gets interpreted. That process, that backing and forthing of a stream of bytes is what we're talking about. Another term you might hear a little bit is the idea of buffering, right? That when I type something into the keyboard and I hit enter, everything that I typed is buffered and waiting for access. And that's why, I could type in a bunch of words on one line and I could read them in word by word, accessing that stream of information and interpreting it bit by bit as I need to do that. Same principle for a file, where we can read the entire line of a file right up to the new line, or we can read the file bit by bit because really it's just a stream of bytes. So that's the first principle. I want to intimidate you perhaps a little bit by showing you what I mean by there being a plethora of ways and classes that are used to access files. And this is the Java input and output package. Remember, a package is like a library. And this is just a small subset of some of the different classes and interfaces that can be used in order to access files. And so you can see we have input streams, output streams. We have a bunch of specific classes that you can use. Some of them are used to access files with data in them. Some of them In Java, you're actually able to take your objects and you can store your objects. Serialize is what it's called. You can serialize your objects into a file, and the next time you run your program, you can bring those objects back into the program. But those all involve different tools, different classes. And so you can access things directly as bytes, you can access them as characters, you can access them as objects, and they all have different classes and different methods of doing it. Here's another view of it. If I want to access files as bytes, then I've got input streams, buffered input streams, file input streams, data input streams. Then there's counterparts for outputting information. If I want to look at characters, I've got the same array of different ways of doing things. For the purposes of this video, I'm introducing you to files. And so we're going to actually stick with just one methodology, and we're going to focus, at least at first, on characters. Just being able to store characters in a file and read them. And what you're going to find is when we narrow our focus down to that piece, that this is actually really easy because it's using the same tools that you're familiar with for keyboards and monitors. There's just a few little tidbits that you've got to get around, and once you can get around those, then the whole process of file input output is quite easy. So what are those little tricks and catches? Well, one of them you already know about, and that is special characters. Please remember that when you're representing strings, that we use that backslash to represent special characters. In other words, if I want to print a backslash to a file, I have to use two of them. If I want to print a quote, I have to use one. More importantly is you have to realize that there are characters that represent new lines, /n/r. And when you read in from a file, those will be characters that you will also be reading in. And the trickiest part is that those characters can be a little different depending on whether you're on a Windows system or a Linux system or a Mac or whatever the case may be. And that can be a little tricky. But I do need you to realize that these characters exist and that you can use them to write, for example, new lines to a file, or to put tabs into a file, or to print certain special characters in Java. So that's just a reminder. Here's the mind-bending one a little bit, and it's about errors. And so the problem with file I/O versus keyboards or monitors is that keyboards and monitors are sort of the default. It's assumed that they're there. When it comes to file input and output, those assumptions can't be made anymore. What if you try to read from a file that doesn't exist? What if you try to write to a file in a file that's write protected? Or the file doesn't exist yet, or there's so many different problems that could occur, and Java will not let you just assume or pretend that those errors can't occur. So we call the errors exceptions. That's the term that I need you to know, and you as the programmer must do something about them. You must. There is no choice in the matter, but there are two different ways of handling them, and I'll talk about those in a second. This is not something new. You have seen exceptions since the first mistake you made in programming. Things like a string out of bounds exception if you tried to read past the end of a string, or index out of bounds exceptions for arrays, or null pointer exceptions if you tried to use something that you didn't instantiate or you didn't create first. The two bits of terminology that go around exceptions are the idea of catching or throwing. So if you think about the exception as some object that is being thrown by the program. So the program sees a problem, it says, oh, it's an exception, I'm going to throw this error. You as the programmer have a choice really. You can either catch that error and handle it nicely and properly, or like a hot potato, you can take this error and say, I don't want to deal with it. And that's called throwing. So you have those two options. You can either catch and handle the error, or you can throw the error. Now think logically about what that means. You call a method that's supposed to access the file. That method throws an error to you. You decide not to handle it, so you throw the error to wherever you've been called from. And they, if they don't handle it, throw it back out, and then it gets thrown again. And eventually you go up the hierarchy, up the stack, until you get to the main method. And when it reaches the main method, your program breaks and you see that error at the bottom. As you can imagine, that's a bad thing. Sometimes in the context of the course, I may say that's okay. But if you're trying to write Windows, the last thing that you want is to see a blue screen of death. Microsoft would never do something like that. You want to somehow be able to handle errors gracefully. All right. There's a couple of exceptions that you're going to need to be familiar with, and these three, I would say, are the ones that you really need to be familiar with. These other ones, not as much, but they may come up. IO exception is at the top of the hierarchy. Any sort of error in input and output is an IO exception. It means something's gone wrong with I, input, or O, output. There are subclasses of that which are more nuanced and more detailed. So for example, there's an EOF exception which says, hey, dude, you're trying to access past the end of the file. We can't do that. That's not possible. Or there's something like this, which I think is fairly self-explanatory. You can't find what you're looking for. It's not there. The file's not there. I can't read from it. I can't write from it. And so these are exceptions that will actually be thrown to you from another program. So I want to show you what this looks like a little bit. So if you don't want to handle an error, this is probably the easiest scenario. You're in a method, and at the top of your method, in your signature, you quite literally write the word throws and the exception that you wish to throw and not handle. And you put that on that signature line of your method. And this really is passing the buck. But if you're trying to do something quickly, you don't want to get bogged down in errors, this will make sure you don't have to handle the errors. You're just going to kind of pass it up and say, I don't want to deal with it. So this has happened by actually adding throws and the exception that you don't want to handle, that you just want to pass on. The other option is that you want to handle it. And when you want to handle it, you're going to have 2 bits of code, 2 bits of terminology. The first is you are going to surround the input and output code with a try block. Think of it, it's like an if block or a while block or something. It's a try block that looks exactly like this. And all of the input and output code is going to go inside this try block. And literally try means, could you please try to do this to the file, please, sir? Thank you. That's sort of what the try means. And then what you're going to have at the end is you're going to have catches for every particular error that you potentially want to catch from this. So catch file not found exception, and you'll notice that this is also a block, and then you can handle that error gracefully however you want. You can put your particular error out. If you're trying to access a file, you could say file not found, enter in a new file name. They enter in a new file name and you try to access the file again. That's graceful. And so this is the way your code would look. You have your try, you put all your code inside here, and then you have a catch. And yes, you can have multiple catches. You can have one for each thing that you're trying to catch, so you can handle different things in a different manner. And then again, you can handle that inside your code. If you don't know how to handle that gracefully, you don't have a nice way of dealing with it, then you could just throw it out, right? You could just use the throw statement instead of the try, but usually you can do something at least, return to the main menu versus break your program. And so that's why, there's usually a way to, the best practice is really to try to catch it and do something with it. So I kind of gave away this a little bit. I mean, how do you gracefully handle an error? Well, if they're in a menu option and they're trying to access a file, you could spit out a message saying can't access that file and go back to the main menu. You could prompt them for a new file name and then try to access that file again, right? What we're trying to avoid is the program literally breaking with an error message. That's anything beyond that is at least handling it in some way gracefully.